Now we're going to do progress check 2.17, looking more at set builder notation. So here we're going to determine 4 elements of each set other than the ones listed using the roster method. So here we got to find the pattern for each one. So here A is going up by 4s. So plus 4, plus 4, plus 4. So just keep adding 4. So plus 4 is 17, 21, 25, 29. What's the pattern here with B? Well, it's weird. It's going that way. So it's going down by 2s. So negative 10, negative 12, negative 14, negative 16. What about here for C? Well, it seems to be odd powers of square root of 2. So then it's like square root of 2 to the 7th, and the 9th, and the 11th, and the 13th. And what's going on with D? Well, this is multiplying by 3 each time. So then this is 3 squared, 3 cubed. So then 3 to the 4th, 3 to the 5th, 3 to the 6th, 3 to the 7th. So there's what I just said for A, what I just said for B. Oh, typos. I meant to say 11 and 13 there. Sorry. And then D, there's the powers of 3. Set builder notation to describe each set. Well, I'm going to use the second type of set builder notation. Notice in our book there's 2 types of set builder notation, and you can do it. I'm using the second kind. I'm not going to go into that full explanation. You should read the book to look at both explanations. So I'm going to use the predicate set style. So you can do it where you can have set and then condition, or you can do predicate and then set. So here's the predicate, 4n minus 3, and then the set is little n in the natural numbers. So in this book, natural numbers start with 1. So that means that my lowest number is 1. So 4 times 1 minus 3 is 1. So I get the lowest number and I keep going up. Again, the lowest number is 1. So I start with 1 and I get negative 2 plus 2 is 0. So there's there. Then just keep going down by 2 as n increases. And then here, again, n starts with 1. So 2 times 1 minus 1 is 1. So that's the first one. Moving on. And then here, 3 starts with 3 to the 0. So I need 3 to the power of n minus 1, because when n is 1, 1 minus 1 is 0. So 3 to the 0. When n is 2, you get 3. When n is 3, you get 9. When n is 4, you get 27, and so on and so forth. So this is our predicate and set style of set builder notation. Okay, now activity 218 asks whether certain things are closed under addition or multiplication. So the set of all odd natural numbers. Okay, so odd numbers, if you add 2 odd numbers, what do you get? You get an even number, so they're not closed under addition. But if you multiply 2 odd numbers, you get an odd number, so they're closed under multiplication. Instead of all even numbers, well, an even plus an even is an even, so they're closed under addition, and an even times an even is even, so they're closed under multiplication. All right, look at this set, 1, 4, 7, 10, 13. Well, these are you adding by 3. Well, what happens if I take 1 plus 4? I get 5. That's not in the set, so it's not closed under addition. What if I do 4 times 7? That's 28. And so will 28 be in this? Well, it's going up by 3s. I think it will be. So it's going up by 3s. So it's 1 more than a multiple of 3. And 28 is 1 more than 27. So you could show with algebra. Let's do it with algebra. So if you created this with set builder notation, so set builder notation for this would be, so 1 plus 3n for n in big N, where that'd be Blackboard bold, the natural numbers. Okay, so if I take, that means this set, these are the same sets. So this lets me say, what does a random number from this look like? Well, pick a random natural number, multiplied by 3 and add 1, and I have a random number for this one. So if I want to see if it's closed under multiplication, take two arbitrary numbers. So 1 plus 3a times 1 plus 3b, where a and b are natural numbers. And then, well, multiply those together, you get 1 plus 3a plus 3b plus 9ab. Well, that's kind of like 1 plus 3 times a plus b plus 3ab, which should look familiar to you based on some of our proofs of even and odd numbers. So it's 1 plus 3 times a natural number. So it is closed under multiplication. All right, let's clear that. What about b is -3, -6, -3, 0, 3, 6, 9. Okay, well, these are multiples of 3. If I add a multiple of 3 to a multiple of 3, I get another multiple of 3. And we'll show this algebraically eventually. And the way to do it is to put this in set builder notation. So this would be 3z. So to put this in set builder notation would be to put it in the form 3n, 3z, 3a, 4a in the natural numbers. So 3 times the thing, if I 3 times one thing plus 3 times another thing, still got a factor of 3 in there. So you can add, multiply, the closed under both. All right, C, well now it's already in set builder notation. Well, this is really similar to that one. It's going to be closed under multiplication, but not closed under addition. Because if I pick a number like when n is 0, you've got 1. Pick another number like when n is 1, you've got 4. So 1 plus 4 is 5, and 5's not in here. So not closed under addition, but is closed under multiplication. D, 1 over 2 to the n when n is a natural number. Okay, well, if I can't add these together because, say, n could be 1. So then 1/2 plus 1/2 is 1. So that doesn't work. And so I can't add them, but I can multiply them because multiplying, let's get out a drawing thing. So 1 over, so an arbitrary number from here would be like 2 to the a times 1 over 2 to the b. And so you multiply, it equals 1 over 2 to the a plus b. Well, is a plus b a natural number? Yeah, the natural number is closed under addition, which means I still have 1 over 2 to the power of a natural number. So it's closed under multiplication. Okay? That completes our last video on this section.